Okay, from this, if I went into the amplitude is the maximum displacement from the rest position. And here's the rest position. So it would be all the way up to here or all the way down to here. It's always a positive amount. And so you could just simply read that right off here. The period is the amount of time it takes for it to repeat its motion. So if it starts here, it's come back, it comes back to here. So this would be one whole period in time. So anyway, you need to think about what kind of sine or cosine function that starts out high and then ends up high at the very end. So it's not starting out at 0. For calculating the instantaneous velocities at 5 convenient locations, what you need to do is kind of get yourself a ruler, straight edge, and draw tangent lines. That's the velocity of a position time graph that's given by the slope, right? So you want to find the instantaneous velocity. So I would pick one like here. That's a really easy one to do. And here's an easy one. It should be, and here's an easy one. So those are pretty easy to find the slope of those tangent lines. Now that's only 3. You need to pick a couple more. I think I would pick right here and pick right here and do the best you can, draw tangent lines and find the slope. Okay, so you're going to be finding the slope of those 5 locations. 3 of them are pretty easy. Once you've found them, then you're going to create a velocity time graph from them. So for instance, this one here, that's going to be 0. So you're going to start here. The slope here, that'll be a negative, so it's going to go down here somewhere. The slope here is 0, so that's going to come back up to 0 for the velocity. The slope here is going to be positive, so it's going to be up here somewhere. And then finally the slope here is 0, so it kind of goes like, wait a second, sorry. It goes like this down, and then it comes back up, goes up higher, and then it comes back down somewhere in there. So, but you have to find out, what those values are, what those peaks are. You then need to figure out what negative trig function that is. So it's going to be a trig function because after it's going to be a negative. Okay, and then it's going to ask you what that maximum speed is. So you'll look at the graph and find the maximum speed, and you have to figure out where and when they occur. So the way you figure out when they occur is just wherever you see that maximum, see the maximum speed. So positive velocity, so I think it was in here somewhere, and the negative, but just speed is always positive, so it looks like the times are probably going to be here. Now as far as where they are, what you have to do is you have to look up here, because this is a position time graph. So you have to look at where it is at those times. Okay. Then from this graph, you're going to calculate the accelerations. Well, this is the velocity time graph, so you have to find the slope. So for instance, in here, I think it's going to be flat, so I would draw a tangent line there. That'll be an easy one. And then over here, I think it's going to be flat, so draw a tangent line there. That'll be an easy one. That's 0 for both of those. But as far as some other points, because I think we have to, oh, it says 3. Well, okay, so there's 1, there's 2. I would probably pick in here for my third point. And then after you've got those, then go ahead and construct your acceleration time graph. And that's also going to be a negative trig function, and you need to figure out which one it is. And you need to figure out what's the maximum acceleration, and you have to figure out when they occur, so the times, and you have to figure out where they occur. So you have to go all the way back up here to figure out where they occur. Once you've figured that out, then I want you to figure out the length. The way you're going to do that is you have to remember that t squared is equal to 4 pi squared L over g. Okay, so this is a pendulum that's swinging back and forth. Up here somewhere you found the period. In part B you found the period. So then you should be able to come down here and figure out the length. And then it says compare the you're going to be comparing simple harmonic motion and UCM motion that we did. And I'll let you go ahead and answer those questions there. Okay. And you kind of want to notice here, to calculate the A, that's the amplitude, times omega, and they tell you how to find omega, and A times omega squared, because those are going to be kind of important, might have something to do with this or this. You might want to check that out. All right, and then on page 2, we have the same simple pendulum, but instead of pulling it back the distance of 0.008 centimeters, now we're going to pull it back 1.6 centimeters, okay, and release it. So it's the exact same pendulum. So if it's the same pendulum, that means it has the same period. Okay, so in other words, it's going to have the exact same period as this one here. So it has the exact same period, but it's going to have a different amplitude. Okay, so you go ahead and make the position time graph, the velocity time graph, just like you did over here, and the acceleration time graph, just like you did over here. And then answer the questions, how does the maximum amplitude, speed, and acceleration compare to the ones you found over here? And when you're doing that, you might also want to think about these answers here too. Okay, and then number 4, a planetary probe equipped with a simple pendulum. All right, so this one here, you're going to be using this idea of t squared equals 4 pi squared L over g, because you're going to calculate the gravitational field strength. You need to find the maximum speed and tangential acceleration of the bob. Your hint is down here. Okay. And you want to find the mass of Mongo. Okay, so let me stop here. Remember we said we have a couple different equations for force of gravity. M times G prime, where this isn't necessarily 10, equals big G M over R squared. The mass that doesn't cancel is the one that causes the gravitational field. Well, you just found the gravitational field up here, G prime. And let's see, we know what the radius of Mongo is. Be careful, that's in kilometers. And so you should now be able to figure out what the mass of Mongo is.